Welcome back to another video on PixInsight, and in this one we're going to look at narrowband imaging. Now I have to tell you that typically if I'm doing narrowband image processing it can take me almost an entire weekend to get it just the way I want it. So what I'm going to show you here is a slightly abbreviated version so that you understand the essential steps without going through the laborious try and test technique where you make a change, it isn't quite right, you go back and try again and try again. So the endless experimentation that you would normally do to make a perfect result isn't going to happen here, but certainly you'll understand the steps and the methodologies that I'm using to get to an image that looks at first sight pretty good. And because of the length and duration of the process, I'm going to split this into a number of different scenes looking at different parts of the image processing so that I can manage it more effectively on screen. So the first thing we're going to do is start with our three stacks. So typically you would have oxygen, sulfur and hydrogen, and these are the unstretched stacks, and if I stretch each you'll see that in the case of the sulfur and the hydrogen the signal's pretty strong, and in the case of the oxygen it's quite weak. First, there's a choice here. Do I process the image as you see it on screen here, or do I process the nebulosity in the absence of stars? Now in the early days I probably would have tried to reduce the stars using morphological transformation and sort of work my way through it. But because of the Starnet module that I showed in a previous video, that so effectively removes stars that there's no real excuse to not try and remove the stars first. Although, as we'll see, it's not perfect, especially around some of these brighter ones where there's a clear halo around the perimeter which will affect the colour balance in that area. The first thing to do is look at removing the stars from these images. And as before, what you do is you do a mild stretch on the image and then run the Starnet module by simply dragging this and drag it onto here. What I'm talking about is a mild stretch. If I bring up histogram transformation and reset it and reset that screen, we're probably talking about something like this, where if you just pull in this slider a little bit you just get a small hint of nebulosity down here. Now if you don't stretch it enough you'll get a strange blocky look to the image after star reduction. If I show you that and back this off to something like this maybe, and then apply it, so if I just get rid of the preview and apply it to the image, now if I run the Starnet, I drag it onto here and come back in a few seconds, you'll see the result. Okay, we're back. All seems well, the stars have disappeared, but if I stretch the image you see these blocks appear. If that occurs then you need to stretch your image a little bit more to make this thing effective. If I go back, take that away and stretch it a bit more and then apply Starnet, I'll get a series of starless images. And here's one I prepared earlier. This is the same image. It's also been slightly stretched just to show you what's going on, and you can see there's some faint residuals from some of the brighter stars, and it may be necessary to use the clone stamp to remove the largest of those to avoid a splurge of incorrect colour around stars when you finally do the final image. And I guess I should really say that the general plan here is to process this image in several parts. To process the narrowband nebulosity and then put in real colour stars at the end. And the real colour stars will come from red, green and blue stacks down here, which are simply short exposures designed to pick up star colour and not clip. And I'm going to pop in the star colour at the very last minute. The clone stamp is a necessary evil. I don't like using it, but sometimes it's the best thing. And there were a couple of big bright stars around here with strange halos. There was one around here and there was one around here. And what you're looking for is a nice even background without necessarily removing or distorting nebulosity. And you see there's a bright star here, and you might need to do the clone stamp here. The radius is a little bit small at the moment, so let's put it up to about 20, and then command click. And now obviously if you set the opacity to 1, that's what you get. If I get rid of that and drop the opacity down, you have a bit more control, and you can tone down the area. Now that might be sufficient, and if I hit OK, it'll now process that, and that star's become a little bit less, or I should say not the star itself, but the bit of haze around it will disappear. Moving on, we're going to take 3 starless images of our narrowband filters and work with those from here on. Let me clean up the desktop and we'll look at the next stage. Just before we dive into the delights of mixing and matching narrowband colours and palettes, it's worth thinking about how we're going to process the sharpness and luminance. Here I've got 3 stacks of the original files, all screen stretched, and while the hydrogen alpha is the strongest signal, the sulfur in this case is actually quite strong, and it's really the oxygen that's the weakest. Sometimes people just simply use the hydrogen alpha luminance information as the luminance for the whole file, but what I suggest to do here is actually use all the data that you have here. So instead of 15 hours for hydrogen alpha, these 3 files together represent about 50 hours of exposure. So to do that, I would typically run the integration tool and run it off the files in the first place. So if I do process image integration and add my files in, I would do S2, my O3 and my HA. And what I would do is simply do an average of them, and 3 is the minimum number of files that you can integrate in PixInsight. So if I look at the integration techniques, I'm going to be doing averaging with scaling based on noise evaluation. And when I run that, it'll create a master luminance file, and it's quite interesting to watch. It doesn't take very long because there's only 3 files, and if I go back into it, into the process console, you can see that one has a weight of only about 11%, the other has a weight of about 50%, and the other has a weight of 100%. So it's definitely weighted it so that the sulfur and the hydrogen are the weightiest, and there's a little bit of contribution from the oxygen. And the end result, if I just get rid of the rejection, is a much stronger signal with better signal to noise ratio than the hydrogen alpha on its own, and this works as a better overall luminance file to apply a little bit of sharpening and noise reduction to. So again, what I would do in this case is a mild stretch as before and run the Starnet star remover on it to produce myself a luminance file. And this luminance file I would process for sharpness and for noise reduction in the background. And the end result of that is this file here. Here the file has had its stars removed and it's been stretched very gently, and then I put a preview window around the principal nebula, which is where your eye is going to go to, and what I'll do is run a sharpening tool on it. And on the sharpening tool I'm going to emphasize very slightly the first 4 image scales, and at the same time I'm going to use a linear mask. And the linear mask basically is a very simple way of only applying the stretching to areas of high brightness. So if I hit the preview and show the preview mask, you can see these are the areas that it will sharpen and the other areas it will not. In fact, in this case it probably needs to be about 3. And I'd apply that, and that will produce the basis of my luminance file. I possibly could do deconvolution on this as well, but the seeing conditions were pretty bad on the night and I don't think it's going to actually improve things. It'll probably just make it more noisy. And what sometimes is more effective is to, when you do your stretching, is to use something like masked stretch, which reduces star sizes as well as shrinking down areas of high contrast. So masked stretch tends to have less bloat in it than the standard histogram transformation. I just thought, as an aside, we just need to look at the luminance, because at the very end that's going to be applied to give a little bit of bite to our colour nebula image. So if I just get rid of that, we can start to look at how we're going to process the colour information, which is really the fun bit. Before we can start combining the narrowband images into a colour image, each of the narrowband files needs a little processing. What you see on screen is the final image just before it's combined as a colour image. And if we go into the History Explorer, I can show you some of the other things that I've done to it. So here, this is initially after the star reduction, and then changed the identifier to starless. I then did a mask stretch that gives me a very faint image, as you can see, and you can see there's some nasty artifacts around here and around here where one of the bright stars was. Back into the History Explorer, there's also some background gradient, so I ran some doses of background extraction to make the background even. So now there's a much better background. It was a little bit darker in the corner here than down here. And then a little bit more stretching and a bit of clipping to make the background darker. So it's starting to come together, but you can still see I've got these artifacts around the stars which are going to cause me some problems. As I mentioned before, we got some clone stamps, and also in this step here we did some smoothing. So I'll show you the smoothing tool and exactly what we did here. Because we're only worried about nebulosity, and typically nebulosity isn't particularly sharp, I removed the first scale by just double clicking it, and on the others I put in quite a heavy dose of noise reduction so that our nebula image is nice and smooth and it doesn't necessarily create colour noise. So back to our History Explorer. Having done that, the image is a little bit softer and smoother, and then some doses of clone stamp to get rid of some of those stars, and that brings us back to where we started, which is a well-balanced image without clipping. So if I run the cursor around here, it peaks at about 0.85, something like that, nothing brighter. If you get above 0.9, then you start to lose colour, because anything that's really bright just looks white to the eye. Now you have to do the same to both the oxygen and the sulfur files. There are ways of balancing up the difference in intensities between the three files. One way is to use linear fit, and if you choose the HA stack, the starless one here, I could apply that to the oxygen and sulfur, and that's one way of doing it, and that's a rather rigorous way of doing it, which means that the balances are very even. Another way of doing it is to do it by eye, and if you bring up your histogram transformation tool and reset it and then track what you've got here, you can see that you've got a bit of baseline here, and you could, for instance, just trim each one individually until you just start to get some clipping and you know that the background level is very similar, and then put the peak of it somewhere in the same place. So you could put it around this marker here, or say halfway between. And that's one way of doing it, is to do it by eye. And it's not a bad way of doing it, and certainly it's worthwhile doing to get the background levels the same, so that you get a nice neutral background when you combine it into a colour image. Picking up the 03, you can see it's a tad darker, and picking up the S2, it's kind of similar but not precise. We can always fiddle with colour balance a little bit later on, but when you look at the three intensities, see the sulfur is quite a clean looking image, the oxygen is quite weak and it is more noisy and blotchy, and it really only has this tiny amount of peak intensity around here, and a couple of tendrils around here which are fairly unique to that one colour, so we don't want to lose those. Another way of emphasising these structures is not to do a standard stretch, but to do local histogram equalization, and quite often I'll run this at 3 scales. I'll run it at about 300 and something with a contrast to either 1.5 or 2, and with a maybe 30 to 50% intensity, and at the high scale I'll run it at 12-bit, and then when I run it again I might be around the 150s, something like that, drop the contrast down to about 1.5 and similar amount and drop it down to 10-bit, and then lastly almost the default settings. If I hit default, kernel radius is 64, drop the intensity down and choose 8-bit. So those 3 together often do enough just to emphasize major parts of nebulosity to make them more apparent on the screen. It doesn't affect sharpness so much as just blows up and emphasizes faint patches of nebulosity without emphasizing the sky background. But you have to be a little bit careful, because around bright stars it can create a dark halo. Fortunately we don't have any stars here, so local histogram equalization is quite a useful tool in these instances. The other thing just to watch out for, as I've said in previous videos, if you're starting to get values that are very high, let's say this one here, what you might need to do is just knock back the highlights. And one way to do that is to bring up the histogram transformation tool, hit reset, drag this to 1.1 or put it in, and then simply apply it to the image. And that'll knock back the highlights from the peak down to about 0.9. And that means you're always operating within the safety limits of the image dynamic, and none of your sharpening actions are going to actually cause clipped highlight values. With our 3 stacks of starless images, it's now the fun part of actually combining them. There are a number of ways of combining images to create a colour image. One of the simplest is simply to use the channel combination tool, where you would simply select your stacks, say this one, this one, and that one, and run it. Oops, always press that wrong button, it's that one there. So it produces a file and you get some strange results. It all depends on which one you choose for which channel. And all this is doing is taking each of these starless stacks and using them at 100%, assigning them to a channel, and that's the result you get. Because of that, there isn't a great deal of control over the outcome. And what would be a nicer way of doing it is being able to blend your 3 stacks so that you can create alternative colours and renderings. Now, the Hubble Space Palette, which is the very common one, actually assigns sulfur to the red channel, it assigns blue to oxygen and green to hydrogen alpha, so you tend to get a very green result. And the second way of combining things is to use pixel math. And with pixel math you can manually type in assigning different combinations of images to form the 3 colour channels. But a more convenient way, and the way I typically use, which is more interactive, is I'm using a script. Now this script isn't part of the standard load of PixInsight, but it is available off the web. And it's called the Multichannel Synthesis script. And if you do a web search for SHO-AIP, so sulfur hydrogen oxygen -AIP, which is the name of an imaging group, you will find a script and instructions how to install it. When you want to install a script, you hit the button here called Feature Scripts, and then you hit Add down here, search for the folder with the script in it, and hit Open, and away it goes. So I can just close that for the moment. I'm going to run this script and show you what it does. Here you have a blank screen and the results will appear here. You also have a preview here. You have a number of options. Let's just get around some of these. First of all, selecting your images. It tries to auto-populate the images, which it does a fairly good job at. So it's identified luminance, sulfur, hydrogen, oxygen correctly. I don't care about R, V and B. This is French, and V stands for vert, which is French for green, but typically that would be the red stack if it's being correct. So you can blend not only narrowband images but also the colour images all at the same time, which sometimes works, and even has one for nitrogen if you're doing that one as well. With those selected, I don't have to worry about it anymore. And down here, this is where you play with your mixer. If I simply run the program and just simply do a quick mix to see what it looks like, it'll come up with an image. So this is the standard Hubble palette, and it's again assigned hydrogen to green 100%, red is sulfur and blue is oxygen. You can play with different mixes. It doesn't have to be 100%. You can start to bring up, put hydrogen into sulfur, and you can do all kinds of different things by mixing different amounts of all the different values. And each time you do it, you'll get a different result. And you can quickly hit that button there and see what it looks like. And it's very useful and it's great fun. The other thing just to watch out for is that there's a number of other options here which do screen transfer functions on things and so forth. You can run this script on stretched and unstretched images. I think it works better on stretched images, but that's just my opinion. Play with it both ways and see which one you prefer. But if you start to find that your background has an overall cast, in this case it looks rather green, you can do things like background auto-equalize, and hopefully when it goes the next time round the background will be more neutral, which it is. The other useful thing with this is you can load and save settings, and I've created a bunch of settings that produce the result that I like. You'll notice that for each of the channels, red, green and blue, that I haven't exceeded 100%. At the moment I've got 70-30 on the red, so at 100%, and equally I've got 80-20 on the green, and on the blue I've got 90-10. So I should get a fairly neutral background because I've got equal contributions going into each of the colour channels, and by mixing some of the channels together it just changes the emphasis on the colours. So if I show you what this one looks like compared to the one on the screen, a couple of seconds later you see the result. It's not quite so in your face. Now this button here that I'm pressing here is simply mixing sulfur, hydrogen, oxygen, nitrogen, red, green and blue. It's not doing any luminance. If I hit this button here, it's the same as doing a colour image followed by the tool LRGB combination. If I hit this one, you should get something with a little bit more bite, and it takes a little bit longer whilst it converts into lab to do the luminance combination. Again, there's no reason why you can't do this manually, but sometimes when you're playing, especially to try and get the final result, it's better to do things with a script to get a result that you like and then play later on. It may not look quite as in your face, but there's a lot more detail here and I prefer the background. If I leave it at that and just hit OK, what I can now do is start to play around with colour balance and intensity. So for instance, if I bring up the curves tool, which is one of my favourites, I can start to play around with intensity and saturation and emphasize different parts of the screen. So if I bring up the preview, shrink this down a little bit so we can see both at the same time, hit reset, I can lift it up, I can drop it down, or if I want to suppress some of the background noise, I can create a sort of S-curve. It all depends on what you're particularly looking for, and at the same time I could increase saturation. I go extreme, or I can drop it down. It all depends on what you're after. So if I close the preview down, so I've got an image now that has a little bit more punch and vibrancy to it, but it's missing something. And what it's missing is the stars. So in the next little scene, we're going to look at how we put the stars in. So in the final stage, we're going to create a star field from our red, green and blue stacks. Now, these are the unstretched stacks, and if I do a screen stretch, you will see that the blue and the green haven't got much, and the red stack is showing a little bit of the nebula. But what we're going to do here is match the intensity of these three stacks together using linear fit. The first step is to get an approximate colour balance, is to take linear fit, use the red stack as the reference, and then drag this onto the green and the blue star stacks. And that way we'll have three images that are similar in intensity range. The next thing I'm going to try and do is combine them together, and for that I'm going to use channel combination. Under colour spaces, channel combination, I would select my red, green and blue. And combining these will create a colour image of the stars. And as usual, I have prepared one earlier. So this is the combination of the three unstretched stacks. Now, the nice thing about star fields is that the stars are inherently much brighter than the nebula. So all you need to do is do a very mild stretch to bring them out. Nothing too much, and trim the background so that it's quite dark. So if you drag your cursor around the background, it's 0.03, somewhere around that. And you can just see the faint hint of some nebulosity around there, but nothing more. And so really what we have here is a black image with stars which are showing good colour. And if I zoom in, you can see that the stars have got a variety of colours from red through to blue, which is absolutely perfect. And this will be very easy to combine in with the other image. One way to combine it into the other image is simply to add the two images together. So if I shrink these down for a second, and if I bring up Pixel Math, again, here's one I've done slightly earlier. I've simply added my stack, which I've called RGB stars, and add it to this file here, and that just simply adds the two files together. And since the background of the stars is essentially black, all it's really doing is adding the points of light. With more challenging images, you would need to amend this approach. You could still use Pixel Math. You would take out this part of the equation, and you would use a star mask to basically replace the holes in the star mask with the star field. But this one is much easier. And the next thing to do is I want to create a new image. I don't want to replace the target image because I want to play. Hitting the square icon produces an image. And if I shrink that down, there is the image with the stars. And if I zoom in, you'll see the stars look very natural. There's no halos around them, which is another advantage of using this approach over trying to use a star mask, because it's quite difficult to get the star mask to closely match the profile of the stars. The other thing you'll notice that adding the stars disguises some of the artifacts in the background. The bit around these bright stars doesn't seem quite as bad, and equally around here. Adding the stars does disguise some of the problems with the background because it confuses the eye and the brain. There we have it. It's not a perfect final image. I would probably do a little bit more tweaking in terms of colour balance and emphasis, but it gives you the basic principles on which to do some narrowband imaging. Just before I sign off, I need to perhaps explain why there's been a bit of a delay in delivering the last of these videos for the meantime, and that is because I also write books. Some of you may be familiar with the Astrophotography Manual, which is now in its second edition, and this is a book aimed at existing astrophotographers who want to get a bit more complicated and advanced. But it isn't for everyone, and it's not particularly for the beginner. So I wrote a different title called Capturing the Universe, which is designed for people who are digital photographers who want to take up astrophotography, and starts off with the simplest of equipment and builds up to a simple system which is reasonably affordable. They're the reasons for the slight delay. This one has quite a bit of work on PixInsight in it. This one does not have anything on PixInsight because I consider PixInsight as being a somewhat advanced program and not really applicable to outright beginners. Well, that's it for now. Thanks for watching. Clear skies to you all, and stay safe.